Okay, so we'll learn about forced oscillations. So, in case of free oscillations, only this force acts, kx, right? And uh, the natural frequency of the oscillations then, say omega naught natural frequency is equal to root over of k by m. Okay. Now, in damped oscillation, this force also acts. This is the damping force. Okay. It is proportional to the velocity, that is dx by dt. Okay. Now, in forced oscillation, there an external periodic force acts on the particle. So, this is an external periodic force. Sorry. External periodic force, right? Excuse me. So, what will be the differential equation to this? So, this m into acceleration equal to minus kx minus b dx dt now plus if not cos omega t. This omega is the angular frequency of the external periodic force. Okay, so x was the displacement of the block. Now this takes this form then d2x dt2 plus b by m dx dt plus k by m x equal to f naught by m cos omega t. Okay. So, as you remember, this was 2 gamma, right? This thing was 2 gamma. So, gamma equal to b by 2m. This gamma is known as the damping coefficient. Now, we will find a solution to this differential equation. As you see, here at start the system goes through a transient state. So, every system goes through a transient state, and after some time the system will attain a steady state. Now, in the steady state we can presume this fact that the oscillation will happen with an angular frequency same as that of the external periodic force. That means the external periodic force will dictate its terms on the block. So, that much we can presume, and we are going to find out the steady state solution. That means, suppose a force is applied on the block, external periodic force, and let some time go and the oscillation stabilizes. After that, x will follow a certain equation with time. Okay. So, in that equation, that means at steady state x will have an angular frequency same as that of the external periodic force, means this omega, right. So, we can presume, let us write the equation again, d2x t square plus, here I can write 2 gamma dx by dt plus k by m will be omega naught square natural frequency, you remember, equal to F naught. F naught is the amplitude of the external periodic force cos omega t. Right. Okay. So what will be the steady state solution as we discussed just now? So steady state solution that is, let's assume x equal to a, then what, cos omega t. Now this omega, I mean the particle or the block will oscillate with the frequency same as that of the force, but we are not sure about the phase. There may be a phase lead or a phase lag. So here suppose you give it change in phase, so the difference in phase, suppose so the phase of x is phi less than the phase of the external periodic force. Okay. Now let's substitute here and solve. So therefore d2x dt2 will be how much? Differentiate it once, you get dx dt, let's write it, minus a omega sine of omega t minus phi. Now we will differentiate it again. So what you get? This cos minus sine, then sine you get cos. So minus a omega square cos omega t minus phi. And now we will substitute these two here in the equation. Let's see. Right. So this will be minus a omega square cos omega t minus phi 2 gamma dx dt here. So minus 2 gamma omega a sine of omega t minus phi, acha, plus omega naught square x, I can substitute here a cos omega t minus phi is equal to f naught by m cosine omega t. Achha. So let's simplify the thing here. So you have omega naught square a minus omega square a, this whole thing, bracket cos omega t minus phi, okay, minus 2 gamma omega a sine of omega t minus phi equal to this f naught by m cos omega t. Okay. So further, if we simplify this equation, here you have to multiply that by this square root of omega naught square minus omega square. Now this whole square into a square plus 4 gamma square omega square a square multiplied by this omega naught square a minus omega square a divided by this thing, this square root is this thing, right, this will come down. So minus 2 gamma omega a, sorry, I have missed out that, multiplied by cos omega t minus phi, right, and again minus 2 gamma omega a divided by again that square root into sine omega t minus phi. Okay, so this whole thing is f naught by m cos omega t, right? So there you can take a outside, right? Therefore a inside root omega naught square minus omega square whole square plus 4 gamma square omega square. Acha. So here sorry, in this case here um, this is actually something, so this will be some cos alpha, suppose this is some cos alpha, so again this one will be sin alpha for the same alpha. So you have cos of omega t minus phi plus alpha equal to f naught by m cos omega t. Now see, these two has to match, right? So therefore we can conclude that alpha is equal to phi, and also we can find out value of alpha. See, this is cos alpha, this is sin alpha, and main important thing is this: the amplitude A, amplitude of the forced oscillation is like this: f naught by m divided by root over of omega naught square minus omega square whole square plus 4 gamma square omega square, right? This is the formula for amplitude in forced oscillation. Okay, now next page we will again write this equation, write this formula and then see what are the consequences. So A equal to f naught by m divided by root over of omega naught square minus omega square whole square plus 4 gamma square omega square. Okay. Now in forced oscillation the amplitude can be maximum when, suppose, say, if the damping is negligible, then this gamma equal to 0, damping coefficient is 0, therefore A equal to f naught by m by root over of omega naught square minus omega square whole square. So now here A is maximum if omega is omega naught, that means, so amplitude is maximum when the frequency of the external periodic force matches with that of the natural frequency of the system. This happens when damping is negligible or damping is 0, suppose, or if damping is negligible, then the frequency of the external periodic force should be close to the natural frequency, right? But if there is damping, so in presence of damping you have to then maximize this A. So in presence of damping, say the question is for what frequency of external periodic force is the amplitude maximum. Okay. By the way, this condition is known as the condition of resonance. That means if damping is negligible, the condition of resonance is the condition for the amplitude A to be maximum. So this is resonance, condition of resonance. This is also condition of resonance in presence of damping. Okay. So we have to maximize A, maximizing A, that means we can minimize this quantity inside bracket. Let's see. So we have to, so for resonance, we have to minimize this omega naught square minus omega square whole square plus 4 gamma square omega square, right? Therefore, so differentiate it with respect to omega to get 0. Therefore, that will be twice omega naught square minus omega square into how much? Minus 2 omega, right? Plus 4 gamma square 2 omega is equal to 0. So this cancels, this means 4, this cancels. Okay, so you are left out with omega naught square minus omega square plus 2 gamma square equal to 0. Therefore, omega is root over of omega naught square minus 2 gamma square. That means in presence of damping, in forced oscillation, the resonant frequency, this is the resonant frequency, is lesser than the natural frequency of the system.